So section 3.6 is almost just an extension of section 3.5. I believe actually the title was Solve Proportions Using Cross Products. Again, there's a minimum assignment, and then I have a recommendation. As I said before, solving proportions is probably one of the most essential skills overall as a citizen, and so the more you practice, the better you'll get. So this is where they're talking about using crossed products. Often I find that students, when the unknown is in the denominator, I would say that at least 50% of the time students get it wrong. They'll divide both sides by 4. Well, you can't do that. So this is where using cross products is helpful. And that just means you can multiply this by that and set it equal to this times that. And the reason that is if you think about it, first of all, I don't like that my unknown is in the denominator, so I'm going to multiply both sides by a, right? Now my unknown is in the numerator, so there you go. There's my 24 times a, which I just wrote over here. And then I need to undo this divide by 30, so I'm going to multiply both sides by 30. And there's my 30 times 4, and these 30 cancel. So that's where cross product comes from. It's a shortcut. Some people don't like it because you guys mess it up when you're multiplying fractions. Like if you see 3/4 times 7/5, for some reason you're like, oh, I cross multiply. No, you cross multiply only when there's an equation in there, and this is why. When you're multiplying fractions, you multiply across the top and you multiply across the bottom. So then I would go ahead and divide both sides by 24. And I don't know, 12 divided by 24 is 1 over 2. So this is 5. Because then it would be 10 over 2. Oh, I should just double check that. 120. Yeah. Sometimes it gets a little more complicated. 2 times x equals 3, and this is what's essential, is to put this denominator as a single quantity. So you got to do the x minus 6 to indicate the quantity, and then you need to distribute, and then you would want to combine like terms. Since my x values are already by themselves over here, I'm going to subtract, which I know is going to give me a negative x, which I don't always like, but since the variable was already by itself on the left side, I did that. And then if you divide both sides by -1, x equals 18. Again, here 4 times m is equal to 5 times m minus 6. 4m equals 5m minus 30. Don't forget to distribute. Whoops. Lots of times. So 4 times m equals 5 times m minus 6. Don't forget to distribute. Often I'll see 5m minus 6. So make sure that 5 gets distributed to both the m and the 6. And then proceed, subtract 5m from both sides. Looks like you're going to get a negative m equals negative 30, etc. Common place for proportions is something like a map scale. So map scales are often given with this colon. 1 inch is equal to 1 inch on the map is equal to 20 feet in actual. And so I really like to keep myself focused and write it as such. Map, actual. 1 inch, 20 feet. So they tell me if the actual distance is 450, how far on the map? And this is where I have map is to actual. So 1 inch is to 20 feet. And again, I just found actual. So where does that belong? That belongs down here. And my question is there. So you can see that your units are going to have to be inches up here in order for these to be equivalent. But you could also see if you cross multiply 20 feet times x equals 480 feet times 1 inch. And then when I divide by 480 feet, my feet actually cancel, and I would get 1/4. Whoops. It would be helpful if I did this correctly. Divide both sides by 20 feet. Teachers make mistakes too. The feet cancel. And this would be 240 inches. 24. Wow, I'm on a roll, aren't I? The 0 is 48 divided by 2 is 24 inches. That's big on the map. I feel like I'm doing something wrong. 1 inch is 20 feet. Divide 4. I don't know. 24. 480 divided by. Oh. 24 inches. That's 2 feet. That's a big map. Anyway, if the map distance is 3¼ inches, how far is it in reality? So again, I have 1 inch to 20 feet, and I have the map distance, so that's 3¼ inches. How do you want to do that? You could do it as a, since it's 3¼ I might use 3.25. I'm not a big decimal fan, but fractions within fractions and decimals within decimals can get messy, and I'm looking for the actual distance. So cross multiply. X times 1 inch. What, this was in inches? Equals 3.25 inches by 20 feet. If I divide both sides by 1 inch, inches cancel, and 20 times 3¼ is 65 feet. And you can look at it this way. I mean, think about it. To go from here to here, I have to multiply by 3.25. So to go from here to here, I'd have to multiply by 3.25. That's often how a lot of people think about it. Sorry about the little derailments during that one. But for the most part, you can solve proportions using cross products.